In a pivotal disclosure, NASA has divulged an uncommon announcement that could modify our spot in the universe. The organization has reported the identification of the primary outsider transmissions exuding from Proxima B, the nearest known exoplanet to Earth, found a little more than 4 light-years away, inside the tenable zone of its star, Proxima Centauri. This disclosure has ignited a flood of fervor and interest across the globe. Could this be the second mankind acknowledges it isn't the only one alone in the universe? The way to this fantastic finding started with NASA's exceptionally detailed perceptions utilizing its advanced telescopes to screen far-off stars and planets, looking for any indications of extraterrestrial life. Proxima B has for some time been viewed as an excellent competitor in the search for outsider intelligence because of its Earth-like elements and its proximity to our own planetary group. The transmission recognized is unmistakable and dissimilar to anything space experts have at any point experienced prior, denoting a potential turning point in mankind's history. The ramifications of this revelation are significant. First, it loans credibility to the well-established scientific hypothesis that life could exist on different planets under Earth-like circumstances. Second, and maybe even more intriguing, it raises questions about the nature of the civilizations that could exist there. Might they at some point be simple microorganisms, or could they be advanced creatures capable of interstellar communication? This transmission from Proxima B isn't simply random noise or a natural cosmic event. It displays an organized repetition that suggests an intelligent source. NASA researchers, working alongside international teams, are now tasked with interpreting this message, attempting to decipher its content and intentions. Mainstream researchers all over the planet are abuzz with speculations and hypotheses about what this message could contain, whether it's a hello, a warning, or something undoubtedly unfathomable. The news of this disclosure has transcended the academic community, lighting up conversations via social media, in government circles, and at dinner tables worldwide. People are shifting their focus to the stars with renewed wonder, contemplating whether creatures on far-off planets may be observing that very night sky. What could their world be like? What sort of technology and culture might they have? These possibilities seem as boundless as the universe itself. Furthermore, this discovery raises numerous ethical and existential questions. How might humankind respond if these transmissions are indeed from intelligent beings trying to communicate with us? What protocols should we establish for extraterrestrial diplomacy? And most importantly, how might such a discovery reshape how we understand religion, life, and our existence as humans? While excitement mounts, there is also a palpable sense of caution at NASA and other space agencies, which are working diligently to confirm these findings and ensure that the transmission is not a misleading signal or a distortion. We stand on the edge of what could be the most historic discovery in mankind's history, so every next step must be taken with precision and care. The world eagerly anticipates further detailed analysis. The detection of extraterrestrial transmissions from Proxima B not only pushes our scientific efforts into a new era but also unites humanity with a common interest and hope. We may be on the verge of answering one of the oldest and most profound questions of all. Are we alone in the universe? Agencies, which are working tirelessly to confirm these discoveries and ensure that the transmission is not a misleading signal or a distortion. We stand on the very edge of what could be the most historic discovery in mankind's history, so every following step must be taken with accuracy and care. The world eagerly anticipates further detailed analysis. The detection of alien transmissions from Proxima B not only propels our scientific endeavors into a new era but also unites humankind with a shared curiosity and hope that we might be on the verge of answering one of the oldest and most profound questions of all. Are we alone in the universe? In April 2019, a spiral transmission was detected from space, specifically from the Proxima Centauri region, about 4.37 light-years away. While this distance may seem vast, it is actually the closest star system to our Sun, lying multiple times farther away than the third brightest star in our sky. The transmission originates from a triple star system consisting of the binary pair Alpha Centauri A and B, alongside Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B are relatively close to each other and share similarities with our Sun. Alpha Centauri A shines with a yellow hue and is 1.5 times brighter than our Sun, while Alpha Centauri B has a softer orange light and is half as bright. Alpha Centauri A is slightly larger than the Sun, while Alpha Centauri B is smaller, with our own Sun fitting perfectly between them in size. But where did the transmission between these stars come from? The pioneering Breakthrough Listen project, dedicated to searching for extraterrestrial communication, has designated this transmission as Breakthrough Listen Candidate 1, or BLC-1. This project, with approximately $100 million in funding, has contributed years of observation using state-of-the-art telescopes around the world. The transmission was first detected by the Parkes Radio Telescope in New South Wales, Australia, which was observing the Proxima Centauri region, the closest star to our Sun. This transmission nearly went undetected amid the vast amounts of data collected during the telescope's observations, but the researchers were able to pinpoint it, like finding a needle in a haystack. To be considered relevant, the transmission must meet two criteria. First, it should be confined to a narrow frequency range, as such radio transmissions are not typically occurring in space. Second, the frequency should fluctuate according to the general movement of the exoplanet relative to Earth. The researchers analyzed nearly 4 million transmissions captured by the telescope, sifting through irrelevant data. They identified around 5,000 distinct transmissions, with one standing out in particular, a transmission that couldn't be explained after cross-checking it with contemporary radio transmitters on Earth. This extraordinary transmission, with a narrowband signature, was only identified when the telescope was focused on Proxima Centauri. It was observed over a 30-hour period, confirming its likely origin from Proxima B. Proxima B, an exoplanet discovered in 2016 using the radial velocity method, reveals variations in a star's position caused by the gravitational pull of orbiting planets. This method tracks the shifting light spectrum of a star, which slightly moves toward blue as it approaches a planet and toward red as it moves away. When these movements are regularly observed over days, months, or years, they indicate the gravitational effect of an orbiting planet. Upon further investigation, Proxima B is very similar to Earth, with a radius 1.1 times that of Earth and a mass 1.3 times that of our planet, suggesting it is a rocky world with a similar density. However, there are notable differences. The primary distinction lies in the planet's position within its respective planetary system. Proxima B is much closer to its star, only 0.05 astronomical units away, whereas Mercury is 0.39 astronomical units from the Sun. This proximity makes Proxima B an extremely hot planet, but since Proxima Centauri is a red dwarf star, the planet receives only 60% of the energy that Earth receives from the Sun, placing it within the habitable zone where life could potentially exist. There are billions of unknown planets scattered throughout the universe, and so far, humankind has discovered over 4,935 exoplanets, with 65 new ones recently added to the count. This brings the total number of exoplanets found to 5,000, marking a milestone in planetary exploration. The James Webb Space Telescope, JWST, is the most advanced telescope ever made, being several times more powerful than its predecessors. With its help, we will unlock the mysteries of the vast universe. To date, we've discovered many planets, from small rocky worlds to gas giants larger than Jupiter, as well as planets that are extremely hot and others within the habitable zone. Among these discoveries, a few stand out, including Kepler 1649c, which is the most Earth-like planet found so far and may even support life. We have identified 55 Earth-like planets, but we haven't studied all of them in depth. With rapid technological advances, particularly with the James Webb Space Telescope, the future holds great promise for further discoveries. One of the main objectives of the JWST during its first year of operations is to identify and study exoplanets beyond our local planetary system, focusing on how they form and whether they could hold water and organic life. The JWST's research on star and planet formation allows us to connect studies of mature exoplanets to their origins, linking them to our own solar system's beginnings. The infrared capabilities of the JWST are excellent for uncovering how stars and planets form for three key reasons. Infrared light can penetrate dense dust clouds, detect the thermal signatures of young stars and planets, and identify essential chemical components like water and organic compounds. Mid-infrared light can pass through clouds that are multiple times denser than visible light, which is essential when observing infant stars hidden within their natal clouds. These infrared abilities allow us to examine and capture the early stages of star formation as gas and dust collapse to form young stars. As these stars age and heat up, massive planets cool but emit more infrared light than in the visible spectrum, making the JWST an invaluable tool for discovering new stars and planets, as well as understanding the physics behind their formation. The JWST's mid-infrared instrument, MIRI, will also search for hot molecular gas near young stars, which could indicate the formation of potentially habitable rocky planets. Of course, Much of the JWST's early science mission will focus on studying how planetary systems are constructed and identifying molecules that could play a crucial role in the development of life. As the James Webb Space Telescope continues its mission, its ability to peer deeper into the universe than ever before will revolutionize our understanding of the cosmos. It is specifically designed to study distant exoplanets and their stars, providing vital information on their potential habitability. The discoveries made through this telescope will be instrumental in revealing whether life could exist on planets beyond our own. One of the telescope's key focuses will be studying the atmospheres of exoplanets to determine if they have the necessary conditions for life. With its unparalleled ability to detect and analyze the chemical composition of distant worlds, the JWST will be crucial in assessing whether these planets can support water, an essential ingredient for life as we know it. By examining the light passing through these planets' atmospheres, the telescope can identify key molecules such as oxygen, methane, and carbon dioxide, substances that could indicate biological processes occurring on these distant worlds. As the field of exoplanet research advances, the JWST will play a leading role in answering the fundamental question: are we truly alone in the universe? This telescope's groundbreaking discoveries will not only provide insights into the potential for life elsewhere, but also help us better understand the origins of life on Earth and the conditions that make a planet habitable. As we continue to explore the cosmos, the implications of these findings will reshape our understanding of our place in the universe and our connection to other worlds. With every new discovery, we are one step closer to unlocking the mysteries of the universe and understanding the vast, complex web